Hello everybody and welcome to our video today where we will be talking about general chemistry, chapter 4, compounds and stoichiometry. All right, so let's get started. First, okay, in this chapter we're gonna have a lot of equations and questions types, okay? So just definitely get familiar with these. And the other point I'd like to make is for the question types, for me, I like to write out steps. So I'm not going through an example, but I'm going out through the written steps that would be helpful in solving those kinds of problems. So for me, I would suggest writing down the steps and then trying to apply it to a problem, maybe look up another video or something like that, okay? So let's get into it. We have our main equation, which is moles equals mass over molecular weight. Know that formula. Okay, know that equation, know the equation, know the equation. Moles equals mass over molecular weight. Mass is in grams. Okay, next we have our equivalent mass, which is the mass of an acid that yields 1 mole, or the mass of the base that reacts with 1 mole of hydrogen ions. Okay, that's the equivalent mass. And then we have the gram equivalent weight, which is the molecular weight divided by the moles of H plus or electrons. We have equivalence, which is the mass of the compound divided by the gram equivalent weight, okay, which again is up here. Then we have normality, which is the equivalent divided by the liters, okay? And then we have molarity, which is the normality, which we just found here, divided by the moles of H plus ions, okay? So personally, I have not seen as many examples with these, but it's still something you should probably know. So yeah, just these red equations here, just make note of them and see if it comes up in any of your problems, in your practice problems. So next we'll get into different question types. So we have if you have to find the grams of a reactant needed and you're given the grams of the product it produces. So in this case, you would find the moles given, so you change the grams into moles using this equation. And then you would do the moles needed equals the coefficient, okay, from the balanced stoichiometric equation of whatever compound you're trying to find the needed for, okay, divided by the coefficient from the balanced chemical equation of whatever compound you are given in the problem. So whatever they give you the grams produced for that compound, you're going to take that coefficient of that compound that you see in the chemical equation and put in the denominator here. And the coefficient of the needed would be the coefficient of the reactant that you're trying to find. So you'd find the reactant that they're asking you for, you'd make sure the equation's balanced, and you take that coefficient that is in front of that compound, and that would be in your numerator, okay? Then you would multiply it by the moles given that you just found in step 1, okay? So again, these are just the steps. But this is a good general equation that I found that helps me figure out the steps, because sometimes I get lost with what moles do I have, what am I trying to find, like there's so many compounds. So for me to write it out in this way is helpful to remind me where I'm getting these numbers from. Okay, and then the third step is just converting the moles that you need into grams. All right, so our next question type is determining the limiting reagent given the mass of reactants. So first you need to find the moles of each reactant given. So you'd use this equation up here, and you'd find the number of moles that they give you, okay? Then you would use the balanced equation to determine the limiting reagent. So you just have to look at the ratios, okay? Based on the balanced chemical equation, you can see the ratios, right? So 1 to 1, 1 to 2, whatever those coefficients are, you're going to use that as the ratio of one reactant to the other, okay? And with that, you'll be able to compare. So if you have 0.5 moles of reactant 1 and 0.4 moles of reactant 2, if they're in a 1-to-1 ratio, that means that you do not have enough of reactant 2, right? to have it enough, you would need 0.5 and 0.5 moles, right? But you have 0.5 moles and 0.4 moles, which means the reactant 2 that you only have 0.4 moles of would limit the reaction of moving forward, because that is the compound, that is the reactant that would limit this reaction, okay? So that is your limiting reagent. Just as a quick example, if you're looking at the mole ratios in the balanced equation, and you're also looking at the moles of the reactants that they give you, okay? And to find the excess grams of the other reactant, you would just use the remaining moles that you have and convert it into grams, right? So the next type of problem is the percent yield. So percent yield is the actual yield divided by the theoretical yield times 100%. So that is pretty simple, but to find the theoretical yield, this is the formula that you would use. So you're going to do the moles of the limiting reagent. So you're going to have to find the moles of the limiting reagent. So you're going to have to use this. The moles of the limiting reagent times the moles needed, the moles of the of what you need based on the chemical formula, the balanced chemical reaction, divided by the mole ratio of the limiting reagent. So again, we're looking at the balanced chemical equation for the reaction, and we're looking at those coefficients, okay? So it's going to be, again, the mole of the limiting reagent that you find up here times the moles of whatever you're trying to find, the theoretical value of, right? Whatever you need, whatever you're trying to find, divided by the mole ratio of the limiting reagent, right? So the coefficient of the limiting reagent in the chemical formula, balanced chemical formula, equals the moles needed, okay? And that would be your theoretical yield. Next, we're going to turn up here, and we're going to have percent composition, okay, equals the mass of the element in the formula divided by the molar mass times 100%, okay? So that one, again, is pretty straightforward. And by this, I mean you're trying to find, in a compound, right, you have multiple elements. So if you want to know what percent of the whole compound one element makes up, that is the formula that you would use. So the mass of the element in the formula, right? And don't forget the subscripts included in this as well, divided by the molar mass of the whole thing, of the whole compound. Next, we're looking at empirical and molecular formulas. So the empirical formula is the simplest whole number ratio of atoms, while the molecular formula is a multiple of the empirical formula to show the exact numbers of each atom. So basically the empirical formula is just a simplified, or in the simplest whole number ratio of the molecular formula. But the molecular formula is what tells you exactly what is in that compound. So if you're given, this is another question type over here. So if you're given the percent composition and the molecular weight, and you're asked to determine the empirical formula. Okay, so given the percent composition and molecular weight, determine the empirical formula. So the first thing you're going to do is assume that it's a 100-gram sample. So if it says 40% carbon, you're going to assume, okay, just for the purposes of our calculations, that is a 100-gram sample. So if 40% carbon in a 100-gram sample would be 40 grams, right? So you're just going to change the percentages you're given into the grams in their respective grams, okay? All right, so if we use the carbon example, right, we will have 40 grams of carbon, and you change that 40 grams into moles. So you'd find the number of moles of carbon that is, okay? And then you'd have to do this for each element in that compound. So however many percentages they give you of each element in the compound, you do that for each element. And then you would divide all the moles that you found by the smallest amount of moles that you found, okay? So if you found that you had 0.1 moles of carbon and you had 0.2 moles of hydrogen and 0.3 moles of oxygen. Okay, so we're looking at 0.1, 0.2, 0.3. Those are all the moles I found based on assuming the 100-gram sample and finding how many moles those grams are for each of those compounds, right? So the smallest amount of moles is 0.1. So now I'm going to do 0.1 divided by 0.1. I'm going to do 0.2 moles divided by 0.1, and I'm going to do 0.3 moles divided by 0.1 because that was 0.1 was the smallest amount of moles that I had, or that I found, right? Then we are going to, the empirical formula is multiplying those integers to get a whole number, okay? So you're just going to multiply those numbers by a factor that will give you a whole number, and that is your empirical formula. So by dividing, you kind of see the ratios that you need, but to get into a full integer to be able to put as a subscript in to figure out the empirical formula, you divided, right, to find the ratio of each element that you would need, but you need to multiply by an integer and figure out what those actual whole numbers would be if you were to put it in a whole formula as subscripts for each element, okay? Then if you had to find the molecular formula for that, from that, right? So that was for the empirical formula. So now if we have to find the molecular formula, you would divide the molecular weight of the empirical formula, okay? So you would find the empirical formula that you just found, you'd find the molecular weight of that, okay? And then you would multiply the empirical formula by the number that you found from that molecular weight. Okay, I know the last step may sound a little confusing, but if you're looking at an example, hopefully it makes some more sense. So I'll say it again. The molecular formula is when you divide the molecular weight given by the empirical formula weight, okay? And then you multiply the empirical formula by the number that you just got from dividing the molecular weight by the empirical formula weight, okay? So remember, in the beginning of the question, we said you would do this if you're given the percent compositions and the molecular weight of the whole compound, right? So you would take the molecular weight, divide it by the empirical formula weight, and then you would multiply the empirical formula, each element and their subscripts, you would multiply that by the number that you just found in that previous step. Okay, so again, the last part might be a little confusing, but once you get an example, hopefully it makes some sense. And if you have any questions, definitely ask below, okay? So I hope you have a great day, and I will see you in the next video.